The popular game Fortnite, developed by Epic Games, suffered a huge threat from a rather simple web vulnerability on one of their subdomains. In 2019, researchers from Checkpoint Research reported a bug in a subdomain created to provide game stats to its users. Using this, attackers might have been able to perform a so-called cross-site scripting attack, which would allow them to gain unauthorized access to the user's accounts by stealing their authentication code. This attack could have resulted in an overtake of countless of Fortnite's 80 million players worldwide, including a loss of their game progress, their in-game currency called V-Bucks, and more sensitive data. But what is cross-site scripting and how can an attacker exploit this vulnerability? Cross-site scripting, or short XSS attacks, are part of the umbrella term injection, and by this are placed third on the OWASP top 10 list of web security application risks, with other injection attacks like SQL injection or command injection. It is very common and probably one of the most frequently occurring vulnerabilities on the internet. In this video, you'll learn everything about what XSS is, what types of different XSS there are, and how an XSS attack is performed, and how you can secure your web application from this kind of attack. What is XSS? Since XSS is part of the injection spectrum, you might find similarities to the web vulnerability SQL injection. But instead of targeting the database on the server side of a web application, XSS attacks are performed on the client side, and by this generate different results. An injection attack means that the attacker injects untrusted input to a program, which then gets executed as a command or query and changes the way the application runs. In case of an XSS attack, the attacker injects JavaScript code that then gets executed on the target's computer. So to understand this attack, it is helpful to at least know some basic understanding of JavaScript. So if you've never used JavaScript before or you want to refresh your memory, check out the JavaScript learning path on W3 Schools via the link in the description. So how does XSS work? As I've said before, XSS means that an attacker manipulates a website and the malicious JavaScript is returned to another user. That means there are two steps that have to be taken to perform a successful XSS attack. First, the attacker has to inject the malicious code, also called payload, into the website. For this step to be executable, the website needs some vulnerability where an attacker actually can inject their malicious code. Afterwards, the victim has to visit the page that contains the payload, and how that attack is performed exactly depends on the type of XSS attack that is performed. Types of XSS. There are different types of XSS attacks, but the most commonly known are called reflected, stored, and DOM-based XSS. The simplest type of XSS is called reflected XSS. This type describes an XSS attack in which the malicious script is directly injected into an HTTP request. For a reflected XSS attack, the attacker has to get the potential victim to execute the malicious code in their own browser. So this type is used when the target of an attack is more a specific person. In most cases, the payload is injected in a link that is then sent to the target in the form of a phishing mail or a shortened URL. So if the victim then opens the link in their browser, the script gets executed automatically. While a reflected XSS attack most of the time occurs by the victim opening a malicious link, a so-called stored XSS attack means that the injection is stored in the application and is later executed when another user visited this website. This could happen when the injected script is stored on the target server, for example, or on a database, a blog post, or on the profile of a user. For the latter option, the code would then executed when another user visited the temporary profile page. The last type of XSS you should know about is called DOM-based XSS. The DOM, short for Document Object Model, is the programming interface for HTML and XML documents, and it helps the program to define the logical structure of the content or style of the program. If you want to learn more about the DOM, put another link in the description to a very great introduction to what the DOM actually is. So in case of a DOM-based XSS attack, the attacker injects malicious JavaScript code that then modifies the DOM. So instead of including the payload in an HTTP response, the attack is directly executed in the browser without the need to load any new pages or sending data to the backend. How to find an XSS vulnerability. Before you learn how an XSS attack can look like, it is necessary that you learn how to find out if a website or a part of a website is vulnerable to an XSS attack. Cross-site scripting vulnerabilities are rather difficult to identify while doing a manual source code review. Since an XSS vulnerability can occur anywhere where user input that is submitted via an HTTP request can somehow be found in the HTML output. Examples for that could be blog posts, comments, or search pages where the string that was typed into the search input field is displayed in the user interface. There are also some HTML elements that are often involved when performing an XSS attack. You should also keep an eye out for. And I want to tell you more about them now. First, the script tag. The script tag is probably the most important part in an XSS attack, since this tag can refer to external JavaScript code and also contain code within the tag itself. JavaScript events like onload can be used to trigger the execution of malicious code. The iframe tag enables you to embed another HTML page in the current page, which could contain JavaScript. And last but not least, the object tag can enable the developer, but potentially also an attacker, to include a script from external pages. As an alternative to manually searching for XSS vulnerabilities on a web page, there are several applications that can be used to scan a web page for any parts that might be suitable for an XSS attack. This can be helpful for the developers, but for attackers as well. Examples for that would be burpsuit or the OWASP Z attacks proxy, or short OWASP ZAP. So for the first example of an XSS attack, we want to perform a reflected XSS attack. And for this example, I'm using the OWASP Juice Shop, which is a deliberately vulnerable website which is specifically made to give its users the option to try out web attacks in a legal environment. I'll put a link to it in the video description if you want to check it out yourself. Alright, now let's begin. As you've learned before, the payload for this type of attack is often stored in the URL. So here we have this web page that allows us to track an order we submitted earlier. As you can see here, the order ID that is used for a query in the URL up here is also displayed in the user interface here. So that could mean that this might be vulnerable to an XSS attack. So in the next step, the order ID up here in the URL gets replaced with the payload we want the browser to execute. So let's see, we're going to put this in. The payload we're going to insert here is just a simple example of a JavaScript alert. What that does, you will see in the next step. So now we're just going to hit enter. As you can see, nothing really happened, but now if we refresh the page, or if somebody would click on the link with, containing the payload, we would see here the pop-up alert, hello victim, which is exactly what we put in the payload. Using the alert function is the traditional way to prove that you found an XSS vulnerability, since it's easy and a fast way to confirm that it's possible to execute unauthorized JavaScript code on the website. The second example is a stored XSS attack. For this example, I'm using the Web Security Academy lab by Podswigger. Similar to the Juice Shop, this lab provides also a deliberately insecure website where you can try to perform an attack yourself. I will also put a link to this in the description of this video. So you already know that a stored XSS attack is usually stored somewhere in the application and gets executed later when the victim of the attack opens the rich page. So for this example, we'll store the payload in the comments of a blog post. So here we have our blog post, and down here you can see the comments, and you can also leave a comment yourself. So in this comment field, we're going to leave our payload, which is just also another simple alert which says hello victim. So now we're going to post the comment. And first we're getting the congratulations, you solved the lab for this one. But what happened, I want to show you now. So if you go back to the blog post, the first thing we will see is our pop-up alert that says hello victim. We can click OK here and go down, and you can see here there's also my comment, but there's nothing written under it because that was actually just our payload. By now, you should have a good overview of what an XSS attack is and how it can look like. But what is the damage an attacker can cause using this vulnerability? Some of the most popular and damaging way to exploit an XSS vulnerabilities are the following. The first would be stealing a user's cookie. Since almost all web applications are using cookies to manage their session handling, by performing an XSS attack like this, you could capture the victim's cookies and using them in your own browser to impersonate the target. The second consequence can be capturing confidential data. So by injecting a payload that works as a keylogger like this, everything the victim types on the web page can be forwarded to the attacker's domain. By this, the attacker could steal anything from usernames, passwords to credit card details. And the last consequence I want to tell you today would be to exploit JavaScript functions. That means everything a user can do by using XSS, the attacker can do as well. So if the application, for example, contains a JavaScript function to change email addresses like user change email, by using a payload like this, you could actually change the user's email and then by resetting their password, overtake their account. Since XSS is such a common and probably one of the most frequently occurring vulnerabilities on the internet, as a developer, it's very important to implement a few countermeasures to prevent any XSS vulnerabilities to occur in your web application. Preventing cross-site scripting is not easy, especially if you want to defend yourself from all the different subtypes of XSS, but there are still some strategies that should be kept in mind when implementing a website. The first strategy would be sanitizing. Sanitizing means the entire removal of certain characters to avoid a value to be even recognizable as code to the application. Unfortunately, implementing proper sanitization is a very complicated and error-prone process, which is also irreversible, so it's not the best strategy to prevent injection attacks like XSS. So the next measurement I want to tell you about is encoding data on output. When encoding is implemented in your application, any special characters that get inserted in input fields or requests are being replaced with a different representation. It's important to apply encoding before the data that is controllable by the user is even written on the page, since you need to implement different kinds of encoding depending on the context. For example, encoding an angle bracket, which normally depicts the start of an HTML tag, in an HTML context would result in this, but encoding the angle bracket in JavaScript context would result in this. Sometimes it's even necessary to implement more than one layer of encoding. For example, in case of an event handler, since there needs JavaScript encoding first and HTML encoding as well. By implementing that, malicious script will not trigger the execution of a function, but rather gets processed by your application as a more or less useless string. Though encoding is one of the most important measures you can take to defend your application against XSS attacks, Sometimes it's not enough to prevent it, depending on the context. So the first thing you should always do when there's any kind of user input involved is validating the user input first thing on its arrival. The most important measurement in protecting your application against all kinds of injection attacks is by ensuring an effective way to validate all variables that are being used in your application's logic. Since an attacker performing an XSS attack needs to insert and execute malicious code in your application. By implementing an input validator, you can easily avoid letting your application even process malicious content. Another advantage of that is that you can also improve the usability of your app by making sure the user puts the correct data into the input fields. For example, you can check if there's a user value that actually contains numbers, if that's what's expected from the value, for example, in a field for a phone number. You can also check if the input contains any special characters that could be used in an XSS attack, like brackets, parentheses, or single quotes. Also, if the input value is expected to be an URL submitted by the user, you can verify that it starts with a safe protocol like HTTP or HTTPS. Last but not least, you should always use an automated vulnerability scanner that reviews your application code and looks for any possible XSS vulnerabilities. Preventing XSS by manually reviewing your code isn't sufficient most of the time, since it's a vulnerability that occurs very frequently and is very hard to find manually. Examples for code scanners would be applications like burpsuit or OWASP. Now, to conclude everything, I hope this video gave you a good overview of what an XSS vulnerability is, how an attack could look like, and the consequences it could result in. But also how you can prevent this vulnerability to occur in your own application. XSS is a very common vulnerability and it's hard to completely prevent it from happening. But by using some defense mechanisms like input validation, output encoding, and automated code review tools, you can definitely mitigate the risk of an XSS vulnerability to occur in your application. Also, as a user, you should always remember XSS attacks when receiving a link from sources you don't trust, since cross-site scripting is a common way to actually perform phishing attacks. You'll find all the links to the resources and the tools I mentioned in this video down below in the video description. And thank you for watching, and goodbye.